Okay, so I've already actually made the majority of this video. There's a few parts that I didn't really care for, so I'm gonna redo them, or I made mistakes in, and this discussion was difficult to understand. So your first step would be, roughing in. That'll all go through. I don't know what order these are going to be involved in the video. I'm not very good at editing yet, so we're just gonna put these down, stuff them in somewhere. They'll probably be together, even though they may not be in order. When you do this technique, essentially you have a square or a rectangle, and you guys have all seen it where your column actually bolts up. So you're going to want to double that rectangle in size and indicate it on your table. This will be after the roughing in, by using a level, an indicator, whatever, without your column. Once you put your column back on, this is going to be the method you're going to want to fine tune it. So put your column back on. You want to get, your spindle as close to center as possible, using whatever. You can eyeball it, you can use a drill bit, a reamer, whatever. Drill bit works good. I'm just getting a rough idea, so get it as close to center that way. This way center doesn't matter as much. This way you're going to need it for the space on the table. This way, as long as you can get a rectangle 27 centimeters long indicated on your table, then it's not going to matter whether you're on this edge of the table or this edge, but you might as well just do it in the center. So once you got that done, I'd probably suggest, do whatever. Mark your center point. That'd probably be the best way to do it. Put a mark right here. And then, so your square, your column back here, and you'll see the math on this later, is roughly 5 centimeters from the center of the bolt to the center of the bolt, and then across, from this side to that side, it was 13.5. So to make this simplified, instead of doing a rectangle, and you can do a rectangle the same size as your column back here, and then it'll give you a 1-to-1 ratio. So if your indicators, I always zero out on this corner because I'm right-handed. So if your indicator is 0 right here and 2 thousandths right here, then that's a direct ratio of what your column's out. I prefer to double my column size, so I would mark my center. To use a square, you can eyeball it. You don't have to be precise, and just mark it right here in the front. So I'd just take a marker, say that's the center, just for reference. So then you can take your ruler, and as I know, since we're doing double the size of my column, I already know what it is. So I would go off my center mark, come out here to 13.5 centimeters, put a mark there, come out the other side to 13.5 centimeters, put a mark there, and then this is where I'd want to be the most precise. I would take my square and mark the back side of my column, or the back side of my table, and do the same on this side. So the square you'll end up with on your table will be double the size, 10 centimeters. So just about mid-center on both of these, and then 27 over your lengthwise. That'll give you a, as you already know, that's kind of messed up, because if you shim this method, if you do your left to right and you shim it, you have a 1-to-1 ratio. You know, if you bring this side down, well, depending on where your depending on where your indicator is touching, your ratio will vary. But if you're, alright, screw the whole ratio part thing right now. With this double the size square, what you'll end up with is you'll end up with a 1-to-1 ratio front and back. So if you bring the back down 5/1000ths of an inch, the front's going to do the opposite. From side to side with the double, you're going to end up with a ratio of 2.7 to 1 this way, and then the ratio of your hypotenuse will be 2.88 to 1. Your hypotenuse, you can check your angles by measuring your hypotenuse on this rectangle that you set up. The hypotenuse of this is 14.4, so your hypotenuse here will be doubled, so it'll be 28.8 centimeters. So with that said, that's how you're going to set up to indicate. And what you'll want to do is you'll want to, as showed in a previous video about attaching an indicator, getting it as firmly as possible, and then get it to where you can touch all 4 corners every time. So that way if you have to remove your table and put it back on, all you have to do is get your indicator to where it'll touch 2 of those corners at the same time, as long as you didn't change anything with the setup of your indicator. And then you should be able to swing around and it'll go right back on your dots for your other 2 corners. So that way you'll be measuring the exact same place on your table every time, just in case there's any inconsistencies. So the other thing I wanted to bring to you guys' attention, especially if you're doing any kind of shimming or filing, as this might help to alleviate some of the headache or wonderment. Okay, so you have your table, and let's just discuss shimming to start with. Okay, so that's your table. You have your column coming up, and you have your headstock coming off with your spindle coming down. Terrible mill, I know, but you guys can see the picture. We'll even put a little motor on top for you. Alright, so let's say, okay, with standard shimming, let's say this side's 1/1000ths high and this side's 0. And we'll just say that this is the front of the table, because normally you shim the front and then you work on the back. So you would put a indicator or a shim underneath the high side, and that would swing your column this way, which would bring this down. You know, essentially you'd do an indicator half, or shim half the width of what you're indicating. But like I said, that depends on where you're indicating. So if you're indicating right at the screw levels of your column, and these are your numbers, then you would do half. You know, if you move out to double that, the amount of shim you would actually need would actually, I believe, change down by 1/4, and so on. You know, if you were to do another, you know, I can't say double, but if you were to add another whatever percent, another 50% on there, then it would move down even more. But just keep in mind that when you do shim, you have to do it respective to the ratio that you are from the bolt pattern that's going to change the swing of the spindle. Now here's my thing with that. Okay, once again, we have your column, your headstock, your spindle, and a very, very bad table. If your table looks like that, send your machine back. And a table. Now, in theory, I call it the pyramid theory, because, let me move my table a little. We're going to move it over this way so it's a little more under the spindle. So I call it the pyramid theory. So in theory, you have from the points of your spindle, you have a pyramid. Now if you were to this is kind of odd because this pyramid isn't, you know, if you think of a pyramid, you're going to think of the pyramids of Egypt sitting on the ground. Well, this essentially is a floating pyramid, like the one on the back of the dollar bill. So if you were to, let's say, pull down on this corner of the pyramid, since the fulcrum point of the pyramid is right here, this corner, and this corner are all going to change. Now this works the same as whether you are shimming or filing. You know, say you were to stick a shim underneath that point of the pyramid, and keep in mind, guys, that this pyramid does correspond with the mounting plate of your column. That is why I'm having you draw a rectangle on your table that is double the size of that mounting plate, because it'll make the application of the math easy. Originally I had done it to where I had a square on the table, and the math just got really confusing. So I had to take a step back and think about it, and decided that if we did a rectangle and a rectangle, it just makes more sense. So essentially the same thing. Back to this, if you were to take, a shim and shove it underneath your pyramid right here, if your pyramid was grounded, this corner wouldn't move. However, this corner and this corner would move. And the theory is, the further underneath you were to stick that shim, the more action you're going to get out of these corners. Same thing with this method. The further you pull down on this, the more action you're going to get out of your opposing corners, because our fulcrum point is not right here as if we were grounded. It is on the spindle. So with all that said, keep that in mind when you're trying to figure out the dynamics of your column. It can be very confusing to the new guy to figure out how all this is. It's like, okay, you get your readings and you say, oh well, that's no big deal. When I first started, I went from the outside corners of my table with my indicator, and it's like, well, I'm going to get the most accurate readings there, and it was quite difficult to get the readings to be what I want, because I would say, okay, I'm one high over here and this is 0, so I need a 0.05 shim. Yeah, 0.1 over here and this is 0, so I need a 0.05 shim, and then I'd stick that 0.05 shim in it, and this one would turn into 0.1 and this one would turn into 0, or however it worked, but I think you understand what I'm saying, because you guys have all probably banged your head against the wall once or twice attempting to figure that out. So with that, and remembering to put a square of the dimensions, I'll show you. It'll be in the math. It's double the size of the column, which is 5 and 13.5 that way, so it'd be 10 this way and 27 that way, and that way it gives you a good spot for indicating. And then I'd use a magnetic indicator with a plunger type is ideal, because you can pull your plunger up and you can gently set it down on the next corner, as opposed to dragging around and having your indicator catch on the lips and catch on the slots in the table. So another thing, if you do have very accurate, I don't think any of my parallels are all that accurate, especially my bigger ones. These ones were shop made by somebody and they're a little off, and all these ones are just they're old and beat up. I have some small ones, but if you got some nice big parallels, you can also put those down and mark on those, but there's nothing wrong with marking directly on your table. Or if you have a tooling plate, you can use that. I set a lot of stuff directly on my table when I'm milling, other than if I'm doing a plunge or anything like that, which I really try not to do. So I just indicated it on my table because it's going to get the most indication. And whenever I do use parallels or anything, I always indicate my stuff accordingly. I'll indicate my parallels before I mount my part on, and then I'll indicate my part. And setup takes me sometimes hours, which is the terrible thing about milling. So with all that said, I'm going to hopefully attempt to cut and glue the hour plus of video footage I have into some kind of rational collaboration and get it on here so you guys can see it. Watch this all the way through, just for the simple fact this is a remake of an actual other video I did, which was done late at night, and I was stressed out by a lot of stuff outside of, you know, just life in general, so I just didn't really take the time to review it and make sure it was acceptable. So here in this video I'm going to try to get down to the basics and discussion of tooling, discussion of technique, discussion of what needs to be done, and then at the end it'll have the math, which will be different for everybody, but it'll give you the general concept of the math. So I'm going to cut through all the bullshit and talking and just try to stick with discussion of getting your mill trammed for perfection. Alright? Yeah, I'm going to go download this, download the other, and play some editing, and hopefully get that done within a couple of hours. I've probably already spent a day and a half on these videos, and honestly I can tell you they're not that great, but the information is there. Just be patient and take some notes, mental, physical, whatever. I previously posted a video regarding tramming. Here's a list of things you're going to need. If you can all see that, and give you a second, pause it or whatever. Time's up. Your work surface you're going to want, you know, something like, you know, like that, with at least somewhat of an edge that hangs over. That'll allow you to clamp things to it. If you haven't, I would recommend for this process, for the best results, especially if you have a Chinese machine, which I believe they all are, to scrape your ways into precision. I made a few videos regarding that. If you guys watch those and have any questions, I will be glad to elaborate. Also, the other thing I would recommend doing is squaring your spindle to your column. One way you can do that is, or at least check it, is, you know, take a square and run it up against your spindle in your X and Y axis directions, and make sure that there's no gap. The other thing you can do, I made a video on it, and I would recommend it. Take the column off, lay it flat on the table. This gets rid of any chance of slop when you tighten your gibs, because if you do it while it is on the machine, you cannot get an accurate measurement. There is going to be some movement every time you tighten your gibs. So the best thing to do is lay your column on its back and get your squareness that way, both your horizontal and your vertical. Therefore, when you lock your gibs, essentially it'll be in the same position as if it's laying on its back, and it'll stay true through the cuts. Do it the other way, you may end up adjusting it the wrong way based on, well, plus you pretty much have to have your column off anyway to adjust it, as the bolts with that are in the back. You have to remove the headstock from the column in order to do any kind of shimming or adjusting. So watch my video on that, and I'd suggest doing that and getting your table, scraping your ways on your table. You'd really be surprised how far they off. This one was off. The carriage was actually cut at 2 different angles. There was 0.02 of a difference between the 2 sides of the table on where the gibs ride. You don't have to scrape under the dovetails. They should be okay as long as you're not getting any binding caused by the dovetails, but a lot of that binding could be caused by the actual flat surface that it rides on as opposed to the dovetails. So align your column or your spindle to your column, and make sure that all your components of your table are square before wasting your time doing this, because if you do this and then you realize that there's issues in your table or in your column squareness, then you're just going to have to redo this procedure. So start at the base and work your way up. Speaking of bases, I'd take my whole mill if I were you, and I'd put it, right in the middle of your workstation. You're not going to want it over there because it's going to be, hard to access all different sides of it and move it around. So you'd place your base directly on your work surface after you've got everything done up. I'd make sure, I'd do whatever you have to as long as your base sits nice and solid and there's no rock in it. This one I actually had to scrape the bottom of the base to get it to sit flush on a flush surface on my surface plate. So once you get this sitting flush and this all squared away, you can put a level on that. I don't currently have a machinist level. This is what I was using. Sorry guys, let me set you down again. So this is just a start level or via level replacement. That's all it is. Normally there's a screw so you can adjust it. You can set it on a surface, adjust it, flip it around, make sure it's reading the same. In this position you can't do this. However, you can lay it in V blocks. And so once you have your base, or I should say your table, leveled, and here it's probably not going to be leveled, but you can use this position and get your measurements in both ways, and it's not going to matter once it's level if it's when you have it mounted. What matters is that you level your table during this operation. So once you level this, we'll come back over here and I'll set up a little makeshift setup. So you're gonna have to bear with me. Okay, so this is your table. We're going to use these right now for example purposes. If any of you have had the column removed from the back of your mill, you will know that there are 4 bosses that it rests on. These are what we are going to work on to square or to tram the table to the column. Okay, so once you have it here, you'd take your level, and this is also where a straight edge or a parallel comes in. We got 2 of them here just as a selection. This one's kind of beat up, but it still reads true. So you get your measurement on your table this way, and then you'd come back and do the same on your on the bosses on the back of the table. Another thing, since I don't have a screw to adjust this, sometimes you can rotate it around and get it to where it actually read. If it's not reading, if it reads here and doesn't read over here, there's something seriously out of square with the setup. So get your measurements, get a rough idea, maybe take a picture with your phone or whatever of where the level sits. Make sure that the level's facing the same way with all your measurements, as this is just a base idea. You're not actually using it to level. And then do the same in your other position on both sides. So you'd go from there to there to there. Same thing, take a picture, write it down. If you're actually getting on the lines, write it down. Maybe write down, this one's got a little nipple on it. Most of them will have that. Maybe write down which way that was facing for future reference. You're not having to count on your memory. And this works. The V blocks work great with this. It doesn't matter which size V block. And as I said, we're just using it for a general reference, not to perfect anything at the moment. So you could probably use a carpenter's level, but I wouldn't recommend it, as the accuracy is willy-nilly regardless. So once you get that, what you're going to want to do essentially, actually let me pause that thought. Okay, so this is a makeshift column for this demonstration. Okay, so we have our column set up here, and another thing you can do is take, and you're going to want to use probably the biggest square you can because you can't bring your table all the way back to the column, but go off, not just off the, you know, you're going to want to go off this part of your column where your actual headstock rides. So you're going to want to go off, you know, this part because that's going to be the flat part. You know, as opposed to right here, because this part does not matter. This is what matters. So with this setup, you know, you'd take and off your table, you'd go off and measure and be able to see at least a rough idea of whether you're squared in. This would be one method of doing it if you didn't have a precision level. Another thing you'll want to do once you take your column off is check and make sure that the bottom of the column, you know, the base down here, is actually, it'd sit more like this, is square with the column. The ways to do that are, I got so much crap here I'm losing it all, guys. Ways to do that are, first you'd put a, you know, a round piece of round stock, preferably drill stock, or pin gauge, or hardened dowels are usually pretty accurate. And then you can run your level off, you know, and run it across the base and see how accurate it is. And you can do that on both sides. And then you can also, you know, run underneath and make sure you're not, you know, there's not a huge unsquareness to your column. If there is, you can either scrape that flat, file it flat, get it true, or you can just leave it as it is and deal with these. Personally, I'd recommend truing this before you go on, but it's not necessary. So with that all said, once you have your rough measurements, if it is way off, oh, sorry guys, I'm getting ahead of myself again. Another thing you can do is you can put yourself a nice flat parallel on your bosses and take yourself an indicator. I would recommend doing one with a magnetic stand as opposed to this kind of stand, although this kind of stand will work, but I would use some kind of magnets or something to pin it down so there's no human error in it moving. And then you can take it and, you know, magnetically attach it to your table and then advance your table across this way, and the same thing with it going this way. You can advance your table and get measurements that way, write them down, take a picture, whatever. That's another way to measure it. Once that's done, you have to rough this in to get, you know, as close of a measurement as possible. You can either do that with a file, well, you can do it by whatever means you can think of to remove metal. You can do it with an air or an electric grinder if you want. I would suggest if you do it with either of those, using like a flap disc as opposed to a hardened disc, as the flap disc is a little less abrasive and it's going to give you a little bit more control. Here's a variety of scrapers. These are all handmade. This one's actually mechanically made. So essentially I just have 2 tension screws, kind of like machinist clamps or parallel clamps. This one again is handmade. I just have a piece of carbide soldered on there, and I actually got this piece of carbide. It's, you know, part of a knife sharpening kit. I think I got it for like $7 for 2 of these at Ace Hardware. And then the solder's like a 450 degree 8000 psi solder. It works pretty good. The solder did bust on me once and I had to resolder it. This is just an old Bridgeport screwdriver I got at the pawn shop for $1. The tip was busted up on it. Here's another example of a soldered scraper. This one was actually a piece of carbide off of a lathe tool that was never brazed on, just a replacement piece, and I just pretty much took my electric grinder and ground a slot in there and then soldered that in there. And this one's been pretty good, although it has no handle, so it's a little awkward at times, and I do end up stuffing things on it to use as a handle. You know, if you do use an electric grinder, just go slow. The other method you can do is filing. Even, you know, I'd suggest using the biggest file you can get. The other issue with files is, regardless, I mean, these seem stiff, but when you're filing something with it, you know, you put one hand in the back and one on the front and apply pressure, well, that causes the file to bow, and then you end up rounding the nubs off. And I actually used a file when I did mine, and I used this, if you all can see this, and this is just a piece of aluminum. I don't even know where I picked it up. I collect scrap from places because, oh, that's a damn good piece of aluminum still. So with this, you know, I took my file and I stuck it on here. And then another thing you guys should all have is, you know, a box of, and this is just part of my collection, but a box of whatever you can use. I got foam in here, got leather strips. I also have a great big huge thing of leather because leather is awesome, especially in the shop. You know, I got little pieces of rubber, just hard composites that really have not much use for anything else. You know, more little pieces of rubber, and I actually think I used one of these, and we'll use that for an example, or I should say 2 of these. You know, so what I did is I put my file on here, and I put my rubber on there, and then I'd hose clamp that on, and I did that just mainly, I don't think I did it on the back, I did do it up here. Oh, have a view of the dirt. I did do it up here, you know, and then hose clamped it on. I don't remember if I did it, I think I did it this way, and I tried to keep as much of the file. And I just did that so my hose clamp wasn't chipping the edges of my file any more than they already are. This isn't the file I used, I just pulled this one out for example. And when you do something like that, you know, the file does have the ability to bend. This, you're not going to bend this. So the other downfall is, something that big, you're going to have to remove your table in order to do this operation, your carriage and everything, because with it on there you're not going to be able to, for roughing in you might not have to, but with it on there you're not going to be able to get access to these to get them truly square. So there's a lot of disassembly and assembly. The great thing is the table's not that hard to put on. You just, you know, keep all the screws out of the saddle, and then you can just slide the saddle off, put it back on, snug up the gibs, and get your measurements. For doing this, if you use the file method, you know, unfortunately you can't just, you know, say your readings are low in the front. I guess I should have brought that up. I had to stop and clear my mind there for a moment. Okay, so after you use the level and whatever means to rough these in, considering that your column's square, if your column's not square, your best bet, and you're not going to square your column, your best bet would be to put the column back on and do an indication the other way. But we'll get into that here in a second. Okay, so assuming that your column's square on the base, and you've checked your levels this way or this way, so varying on how it is, you would rough this in by removing to level in this manner. Now, by doing so, you can't just, take a file and say, okay, well, I have, we'll say that this is 100ths high, for example. It's exaggerated, hopefully, but okay, so I need to remove 100ths from this side in order to get this level with the table. So I'm just going to file this side. You can't do that. You need to compare all 4 of these corners at the same time and file accordingly. So say you need to remove 100ths from this side and say 5,000ths from this side, and I'd use fine files. They remove a lot less, or I should say single cuts, or even a mill bastard's alright, I suppose. Just I'd use a single cut because they're a lot better for this operation. So you'd start with this and you'd keep the majority of your down pressure on the side that you're going to need to remove the most from. I'd say using this file because you're going to get a lot more taken off at the same time, and these are exaggerated in size. The bosses actually are just barely, probably wider than this file in this dimension, and I think they're thinner than this file in this dimension. So you'd start with this, you'd keep the majority of your weight on the highest side, but periodically, you only want to take maybe half a dozen strokes this way and then go over and do this and then do it at an angle. You're going to want to remove material from all 4 at the same time so you don't end up with them staggered in different directions. So it's going to be a method where you have to purposely kind of get all 4 of them at the same time to keep them flat, and that's why I recommend having a backing on your file that's going to keep your file from bending, so that way when you're doing this, if you do that and you get all the directions, which are this direction on these 2, this direction on these 2, this direction, and then give it a real good on the angle directions, you should move all these down at a consistent rate with each other. Okay, so I've centered this, and I actually used a drill bit. Got my fancy little makeshift stands in the way. So I used a drill bit just to eye this in with my center lines. And it doesn't have to be perfectly centered, but the better the center, the better you're going to get. So I use that to eye it in. As far as where the table is located, having the table centered would be your best bet. You just need your spindle centered over the center line of your table. I'll show you why here in a moment. So with that done, and you can use a drill bit, whatever. Make sure that the drill bit's nice and straight though, put it in, turn it on, so that way you're not too far off, or even once you have your table, you believe your table centered, go ahead and give it a hand spin just to make sure your end of your drill bit's not 3/32 off, because they do get that way. If you use a good, decent quality drill bit, you should be alright. This indicator isn't the one I would use. I'd use a plunger type. I'm just putting this in for example. Okay, so once you have your spindle centered above your table, I used my front mark, put a square on my table, marked up my back. So this way I have relatively a dot in 4 corners that are relative to my center point of my spindle. and these are going to be used reference marks. So once this is done, I would suggest, I mean, you can lock it like this, but that might kilt your table a little bit. I'd suggest just at least, you know, picking 2 of the gibs on opposing sides and tightening them down to make sure that this doesn't shift out of position. As far as the front and back, it doesn't matter because you're probably going to be taking the spin or the saddle and the table. You'll probably be sliding it off as you do adjustments. And you know, once you have these 4 marks and you keep your indicator the same, I would use a magnetic indicator setup or a solid indicator setup, and having the most solid indicator between the arms so you're not getting any flex in your indicator when you're touching the table is going to be crucial. I think you guys all know how touchy indicators can be. So if your indicator is touchy, or if you go to move it from point A to point B, especially with a plunger type, because you kind of want to pull up the plunger when you go off the edge of the table and then set it back down gently. So having a good solid setup out of, whether it's clamped onto your spindle in a collet, whatever, is crucial for this. And as you can see, I'd need to adjust this in a little bit, but as you can see, as I rotate it around, I can pick the same point on the table every time. So when I remove my table and put it back on, I can always line it back up to where it was. Or once you have this roughed in, this is the tedious part, you have to remove your column and put it back on numerous times. Once you start filing these, you'll see how the finishes are on these mills. They are anything but flat. You'll end up with, say this is the boss, and you'll use a file that's mounted to something so it's flat, or you'll put, this is also a handy tool, and I'd actually recommend having, either a decent straight edge. And what you do with that is when you're doing your filing, you can take your straight edge and a flashlight, and you can at least see and make sure that you're keeping all 4 of these filed down square to each other, which makes a big difference. You could possibly also use, a long parallel if it's nice and straight, and do the same thing, or maybe use the edge of it, because when you have it mounted down like that, it's really hard to see a flashlight underneath. Or you could use some Dykem or something like that, but then we're talking getting into a whole new mess, and it's just gets into a headache. You don't have to file either. Like I said, you can scrape. You could use mechanical method, but I wouldn't do that much past your roughing in stage. So yeah, like I was saying, if you look at these after, once you start filing, what'll happen is you'll see that the file's touching here and here and here, and that's it. And then as you keep filing, you'll notice that the area that you're filing is growing, and you'll be able to tell because it'll be shiny. So these things are anything but flat as you're doing it, and so that's why I'd recommend even making sure that the bottom of your column is square, because if you get these 2 surfaces of metal, say that this is, here's 2 surfaces of metal, but let's say that these are the, your bottom surface looks like that, and your top surface looks like that. Putting this together where you're going to keep tram is not gonna last, because as your mill vibrates, and as you use it, as you're pulling up and down on your column, these 2 spots are gonna wear, and the high spots are gonna pack down, and it's gonna become more and more mated together. Whereas if you do this by hand and you get these 2 surfaces as flat as possible, in time there's going to be a lot less to wear down. So your tram is going to hold for a lot longer, requiring less and less as you go future maintenance. I mean, you're always going to have to conduct maintenance, but it's going to minimize the amount of maintenance. Now, let me show you what I used for the math, and then I think I'm going to wrap this up. Oh yeah, the other thing, when you're squaring this column, go all the way back to the beginning. When you're using a square for roughing in, you know, you can use feeler gauges and stick them underneath whatever legs of the base to get your table square so your level will read. And then you can, you know, once you have your whole base and everything and your table square, it doesn't matter if it's square to the world or level, you know, if you can get it to where you can read on the level, it'll make roughing it in a lot better. Because say, you know, this is the whole setup, the whole base, and these are going to move with this at the moment, so keep that in mind. So, you know, you set your mill down and your base is, you know, tilted like this, and then you put your level on and your bubble's all the way on one side, and you do the same and it's all the way over here. You're not going to, you know, it's going to take forever to figure out what's going on. So shim up your table, and that's why I'm saying have a good solid workspace. Shim up your table, and hopefully these will move, well, these will move in correspondence with your table until your table's relatively level to where you'll be able to see what the true difference is between these on a plane that's level to the world, as opposed to a plane that's tilted and all you can see is a bubble up at the top side. Like I said, that's only if you're using the level method. If you're using the indicator method, where you use an indicator on your rear and you just move your table back and forth to see how your indicator reads, it's not going to make as much of a difference. If you don't do any kind of work to your ways, and you know, like I said, what happened is my saddle was, you know, on this side, it was in this kind of a plane, and it was almost, you know, 1/1000 and a half high on one side, and then it was also tilted like such, so it was, one corner was way higher than the other corners, so it made it very difficult to figure out what was going on. And on top of that, if you do an indicator type method where you run an indicator back and forth, it's not going to make, you're not going to get any kind of accurate readings if every component is not level with each other. You know, if you're cranking this table over and the table's actually rising and your indicator's, you know, set in this position running on a parallel back here, your indicator is rising with your table, which is going to give you false readings back there. So if you do the indicator method, everything needs to be running true to each other before you can true up your column through that method. The level method, you can true up your column at least to how your table is setting without doing that method. So keep that in mind. Hopefully you're watching this full video and not just jumping through. Alright, so now here's the square. Will need to be 10 centimeters this way, which I believe we have just enough clearance. So 10 centimeters, which will work out perfect. And then you're going to want 27 centimeters wide. I'll explain the reason for that in a moment. So let's take a look at the math. I don't know how much of this you guys are going to be able to see, but I'll start up here and I'll write small. I'm just joking. Okay, so we have the table. Well, this isn't the whole table. This is the rectangle you drew on the table. I suppose I can move you guys a little bit closer. We'll just go through this in steps. So, this is the rectangle we drew on the table. Above that, you have 4 squares, and these are actually separated, but we're just going to make them for ease of use. There's a space in between here, so we'll make that a thicker line. Okay, that's our space. Okay, so let's just number this. We got corner 1, corner 2, corner 3, corner 4. And then we have 1, 2, 3, 4. So our corners of our column correspond with the corners of the rectangle that we hypothetically drew on our table. I suppose you don't actually have to put dots, but I'd actually put a dot at each corner of the rectangle, so that way if you have to take the setup apart and move the indicator, move the spindle, anything like that, it'll be very easy to get it back. You know, all you have to do is get it to 2 dots and it'll automatically swing around to the other ones, unless you change the actual like setup of how the indicator is mounted. So, and I'm going to keep nice easy numbers. If you followed, you know, it's not too hard by paying attention and being diligent to and following, you know, the scraping technique and the leveling technique to get this within, you know, 2/1000ths of an inch. So stating that, let's assume that our worst corner is 2/1000ths of an inch out. So we're going to make this corner 2/1000ths. We're going to make this one 5/10,000ths. We're going to make this one our 0, because I always 0 on my right corner. And then we're going to make this one 1,000. And your numbers are going to change. They're not going to be the same as this, but this is just using nice round numbers to give you a good example of the math that you'll need to do to achieve this. So with that said, we will take our next step over. We'll come over to this empty spot. Now we have the sorry guys, I gotta look at my cheat sheet here. Okay, so we have our 4 corners on our table, and okay, no, this is actually the 4 bolts of the column. Our table will be twice this size, but the space between my column appears about like this. This may not be perfect, but we got 13.5 centimeters, 5 centimeters, and then our hypotenuse, if we make this into 2 triangles, is right there, and we have 14.4 centimeters. Alright, so with those numbers, and even on the table, this is all that matters. The table will actually be, let's go back to this, the table will be doubled. You could do it this size, but it's going to be easier to get accurate readings. Crap's falling over. Sorry guys, hold on. Be easier to get accurate readings if you double this size on the table. So 27 centimeters for that side of your square, and then this side will be 10, obviously. Okay, so the next thing is the ratios between all these corners. Alright, so our top corner here, we have, because what happens is actually your spindle will be centered right here, but we can't change all of these corners at the exact same time. Well, actually we can, and I'll discuss that at the end, but most people won't have access to do it. So this is how you do it without the access. So our ratios is, on this top line, it's 2.7 to 1. This line is 1 to 1, and our hypotenuse is 2.88 to 1. Alright, so with that being said, we're going to take, essentially, okay, I may have made another error too. I think I said earlier, file the low side. That'd be incorrect. When you're using the level or the indicator to decide where you need to rough this in at, you'll see automatically which side's higher, and you're going to need to file that to get the sides even. So obviously there you're going to be filing the high side. With this, you know, if our column's leaning this way, that means one right here would be the high side. And in order to get this to straighten up, we're going to need to file the high side. Actually, I was thinking that these were all negative probably. If this is 0, everything else would be negative. To figure out how much you need to remove from this to get these into a better number once you set up your indicator, because you already got it roughed in. So we'd take the high side, which is the 0.002, and figure out how much we need to remove from that. So right, remove here. Okay, and to do this, we take 1, which is the high side, and that is 0.002, and we're going to divide that by the hypotenuse ratio, which would be 2.88, and that is going to equal, in this case, 0.0006944 repeated. Sorry, didn't even look in the camera. Alright, so we're just going to round this. So I'll write round here. In case you have to refer back to this without wanting to watch it, you could just pause it when it's all done. So we're going to round this up to, we'll just round it up to 7. So 0.0007. Okay. Now since the square we're using on the table and what's actually indicating is double the size of our actual column square, we're going to divide this by 2, and that'll equal 0.00035. So we need to remove 0.00035 from 2, and I'm going to show you what that does. So once again, we're going to do 0.002. This is some simple subtraction here now. Minus 0.00035, and that's going to come up with 0.00165. So I'll draw it over here, I guess. The new dimensions of our square on this corner is going to be 0.00165, and this might not seem like we're getting very much out of it. I'm just actually going to move this over here. Might not seem like we're getting much out of that, but you'll see what's going on here in a minute. So once we remove that, that's going to add to 2, 3, and 4 respective their given ratios. Okay, so, and as I said, add 2. So this was 1, so we'll put 2 here, which will be our you guys remember 0.005 corner. So we'll go, and you got to remember to multiply the ratio in here. So we'll go 0.035. Oh, running out of room. Times 2.88. 0.7. As you guys remember up here, the ratio across the top would be a 7 to 1. And that's going to give us 0.000945, and we're just going to call that let's call it 0.00095. So move back over here, readjust this camera a little bit. So we have 0.00095. We're going to add that to whatever's on that corner, which will be 0.0005, and that is going to equal 0.145. So this corner now becomes 0.00145. And we move on to 3. The same method. We'll do the, well, this one is the 1-to-1 ratio. Sorry, where am I at? Right here. It's the 1-to-1 ratio, so we're not going to multiply it because we're going to come up with 0.00035 as the multiplier. And then we're going to add that to the ratio that is there, which is 0.001, and that obviously is going to equal 0.00135, and we're going to put that up here. And then 4, and we're going to do 0.00035, of course. And this time we're going to multiply that by the given ratio, which is 288. So 2.88. I don't know what the hell that was. It's not an 8 though. And that equals 0.001008. Alright, so we'll just get rid of the 008. Doesn't do us any good. And we will make this corner 0.001. Alright, so that is the math that goes behind this. Now, respective of their corners, obviously, when we zero our whichever corner we choose to go from out and re-indicate, we should end up with a 0.00045, a 0.00065, and a 0.00035. Now I suppose if you really want to, you could repeat this process, but all things considered, if you followed the filing technique I showed you, as you're going to have to pull this apart and hand file it, and you did the cross patterns and you applied the majority of your pressure on your high point with the least amount of pressure on your low point to keep all 4 of these corners even with the column, so that way you're not ended up with, you know, pitched in bosses that don't sit flush on the base of your column, because that's not going to do you much good. Then theoretically, if you did that, all of these should have been, you know, these numbers would be much lower at the end, regardless of the math, because of the way it was filed, you know. So they should be much lower. And, you know, to address this, let's say you're using a 2-inch fly cutter, to show you how minimal this is. Okay, so 10 centimeters, that's the short side of your square, divided by 2.54 inches per centimeter will equal 3.9 inches. We'll just call that 4. And so we'll call it 4. Half of that is 4 divided by 2 is 2, so we'll call that 2 inches to the halfway point, which would actually be only an inch on your indicator, but either way 2 inches. We'll divide that by, if you see here, the worst number's off. I mean, we're between these two numbers, we're 2/1000ths of an inch difference. Between these two numbers, we're don't know what the hell's going on there again. 0.0003 thousandths of an inch difference. Here we're 0.00035 thousandths of an inch difference. So the worst two are between here and here, which is 0.00045 thousandths of an inch difference. So, you know, so we'll divide this. Obviously, we'll cut that in half. So we'll divide that by 2. It's 0.0000225. So we'll just round that down to 2. 0.002 divided by 2 inches. So essentially, in a 2-inch fly cutter, between the two sides, you're going to be 1/10,000ths of an inch difference. And that's if these numbers are precise. Like I said, these should be lower if you filed in the technique that I discussed. You know, if you get down to, I don't know, say a 1/2 inch end mill or something, you know, then this number would actually be 2 divided by 4. So it'd be, we'll say 1 divided by 2. So we'll say, you know, 5/10,000ths of an inch difference over the size of a 1/2 inch end mill. And, you know, for a mini mill, that's more than acceptable tolerances for something you're cutting. So that is the messed up math regarding once it's all dialed in, or roughed in anyway, on how you decide how much you take off per the high side. And just to give you a reminder, we'll pan over this once more, see if it does any good. Of course, you got a great big light. Oh, there we go. So we'll pan over it in an angle. So that's the basic setup. And we'll give you one from a distance. This camera's pretty good. It'll probably show up pretty good like that. So there you go. That's the basic math once you get it roughed in. If you guys have any questions, send me a message. Thanks. Bye. Okay, so I almost forgot. The other method I said I would discuss was another method you could use to tram your mill, which would be a lot easier, but you would essentially need access to a bridge port for the most part, a large fly cutter. And what you would do is you'd have to go through the whole system of scraping all your ways on your base, your saddle, your table, and your column, as well as the back of the headstock, and get everything square to each other. You would have to square your spindle to your column, as I discussed in one of my videos. And once that's all done, you could essentially take your whole column with your headstock and spindle attached firmly, put I'd say a large collet, hopefully a very precision one in, with a nice straight piece of drill stock. Use the bridge port to indicate it to where your drill stock is, where you're not getting any indicator readout on your drill stock on both a horizontal and vertical, we should say, but essentially it would be on the top side and the side of it, just as if you were doing aligning your tailstock with your bedways sort of action. And once you have that to as perfect as you feel is necessary, I would say, you know, a thousandth of an inch in 10 inches would be pretty accurate. Then you would want to, you wouldn't be able to use a fly cutter on this method unless you turn the Bridgeport, unless the milling head turned 90 degrees. But you would essentially want to take an end mill and mill off your column base to match your spindle after it's all been squared to your column. And that would essentially square the base of your column and spindle to each other. Now once that's done, you would remove your column and spindle setup from the mill, and you would put your table setup on there, and you would do the same thing. You would, you know, probably have to shim up the base and everything, and this is why you would want all your components of your table, your base, and your saddle to be true with each other, is because, like I discussed earlier, you know, my saddle was cut at 2 different angles. So if I was to indicate that in this method and then cut it, I'd be cutting my boss at those 2 angles as well, and it would never become square. So if I have all that square, then I could set my entire base with the saddle and the table attached, everything snugged up nice and tight onto the table of the Bridgeport. I could indicate my table to where it's essentially on a level plane. I mean, you'd want to make sure the Bridgeport mill head is trammed in, of course, but indicate that to where it's on a level plane, and then you just put in a fly cutter and fly cut your bosses. Now, I haven't tried this method, but the math behind it is sound. I mean, if you have the equipment to mill your column base square with your spindle, and your bosses that your column rests on square with your table, then essentially you would put it together and it should be square to the world. Like I said, I don't have the equipment to try it, so I can't, but if you guys do, you could try it. I mean, the worst that's going to happen is you're going to put your column on and you'll be a thousandth or 2 off, and then you'll have to probably put your table back on, set it up to you know, put a shim underneath one side to correct for the difference, and remill the bosses. If you do this method, make sure you pay attention to your fulcrum points. As said, if I was to put my table on the mill, the column's not going to matter as much because there's really no fulcrum point on the column. It's the 4 bosses on the table which create a fulcrum point. So if I was to put my table on the mill, I wouldn't indicate out past where my base bolts to. Wait, how would you do that? I wouldn't indicate out past where my column bolts to my base. No, correction, where my base bolts to the table. So the 4 bolt holes in the base is where your fulcrum point would be if it was sitting on the mill with the base down on the table. So that would be my indicator point, because that's where you would end up shimming to correct your column if it was at a square. So that would be the final method. If somebody has the equipment to try this, or has a friend who has the equipment to try this, feel free to let me know how it works. I would be glad to know. Thanks.